So, have you noticed how ancient, long extinct monsters are suddenly, well, kind of walking the earth again? Obviously not in physical zoos, but they are absolutely resurrecting on our screens. Today, we're diving into this incredibly fascinating intersection of paleontology and digital media. We're going to unpack exactly how the power of algorithms and viral video formats are fundamentally changing how we understand the deep history of life on Earth. It's a wild ride, so let's get into it. Okay, let's dive into this. We've got a great roadmap for today's explainer. We're starting with the digital paleontology boom, then we'll compare horizontal versus vertical formats, check out some viral meme fish, explore the nightmare megafauna of Australia, and finally, we'll tackle the ongoing war between scientific accuracy and the almighty algorithm. Section 1. The digital paleontology boom. For decades, science communication was super rigid. If you wanted to learn about the fossil record, you pretty much had to rely on traditional broadcast TV or heavy institutional gatekeeping. But today, the whole structure has totally transformed. It's been completely democratized by YouTube's creator-driven environment. Now, what's really interesting here is that massive number. 757 million. That is the total number of views amassed by PBS Eons, a digital-first educational channel focused entirely on deep-time science. I mean, when you look at a figure like that, it proves beyond a shadow of a doubt that there's an immense global appetite for this stuff. This isn't just a niche hobby anymore. The audience is absolutely massive. And this whole boom is being driven by incredibly dedicated creators. Take PBS Eons, for example. With over 3 million subscribers, they're so successful they're actually transitioning into a long-form television series. Then you've got creators like Lindsay Nikole, a zoologist who just started making solo TikToks back in 2020. Fast forward to today, she's rocking over 2 million YouTube subscribers, over 500 million views, and works with a full team of researchers. And then there are channels like Extinct Zoo, commanding well over 1 million subs by crafting these highly suspenseful documentary-style deep dives. We are quite literally witnessing the professionalization of the digital fossil record. Section 2, horizontal versus vertical formats. But how exactly are we getting all this information? Well, it really comes down to how the internet is built today. And this brilliantly illustrates the divide we see in content creation. On one side, we have horizontal, long-form videos. These are all about narrative depth. Creators bring in scientific consultants, build custom 3D animations, and really foster sustained intellectual engagement. But on the flip side, we have vertical, short-form videos. These are heavily engineered for rapid sensory engagement and algorithmic amplification. They rely on artificial intelligence assets and instant emotional triggers, mostly fear or curiosity, to just grab you in seconds. You can see exactly how these formats perform when you look at the raw data. Extinct Zoo's horizontal documentary on prehistoric Australia pulls in a jaw-dropping 9 million views by using a slow-burn, high-suspense narrative. Meanwhile, Fossil Facts uses a quick, sensory, vertical format to reveal that dinosaurs didn't actually roar, instantly capturing 6 million clicks. It just goes to show that each format demands a completely different strategy if you want to maximize educational reach. Section 3. Viral fossils and meme fish. So what kind of ancient animals actually work best in these formats? Let's move to the timeline and see how this builds across deep time. We're talking about a timeline spanning hundreds of millions of years, from the strange jawless fishes of the Ordovician 450 million years ago, through the devastating Permian mass extinction, into the massive reptiles of the Paleocene, all the way up to the giant mammals of the Pleistocene just 2.6 million years ago. Our digital algorithms are literally plucking distinct stars from each of these eras. Take this little guy, for example, from the Ordovician period, Sacabambaspis. As Live Science perfectly summed it up, this was a jawless, armored fish with forward-facing headlight eyes and an eternally open, D-shaped mouth. I mean, emotionally, he just looks like there are absolutely no thoughts behind those eyes. But here's why that actually matters. This visual novelty completely bypassed traditional educational barriers. Thanks to internet meme culture, a highly obscure 450 million-year-old fish became globally recognizable practically overnight. Now, when we jump over to vertical short-form content, the algorithm absolutely loves extremes. We're talking massive physical dimensions and intense climate-driven survival. On one hand, you have Titanoboa, this Paleocene monster snake over 14 meters long that thrived in tropical warmth and could constrict prey with 400 psi of force. To put that in perspective, that's the equivalent weight of 3 Eiffel Towers. On the other hand, you have the woolly mammoth, the ultimate symbol of ice age endurance, rocking a double-layer coat and snowplow tusks for sub-zero climates. These extreme biological adaptations are just perfectly engineered for rapid, viral storytelling. Section 4. Australia's nightmare megafauna. But if creators want a sustained, highly engaging, long-form narrative, they almost always look to one specific place and time, the absolutely terrifying ecosystem of Pleistocene Australia. To get why this content gets millions of views, we have to talk about Sahul. Because Australia separated from the supercontinent Gondwana and drifted northward in total isolation for tens of millions of years, it became this unique evolutionary laboratory. Without the large placental mammals found basically everywhere else, Sahul developed a completely alien ecosystem of giant marsupials and incredibly deadly reptiles.
Seriously, look at the absolute monsters that ruled this land. Mammals were definitely not always in charge. You had Megalania, a giant relative of the Komodo dragon growing up to 7 meters long, fully weaponized with serrated teeth and toxic venom. Then there was Stylocoleo, the marsupial lion. It didn't even have canine teeth. It had these blade-like premolars that sliced like industrial shears, plus raptor-like thumb claws to ambush prey. And honestly, perhaps the most terrifying was Quincana, a crocodile that just completely abandoned the water. It evolved long limbs positioned vertically beneath its body, basically transforming it into a fully terrestrial pursuit predator. No thank you.
And the herbivores they hunted? Just as bizarre. We are talking about Diprotodon, literally a car-sized wombat weighing up to 3,500 kilograms that migrated in massive herds across the savanna. Right next to it was Procoptodon, a 500-pound kangaroo that got so heavy it actually lost the ability to hop efficiently, so it traded hopping for a bipedal, upright walking gait. These were spectacular giants. But sadly, roughly 45,000 years ago, a brutal combination of severe climate change and the arrival of early human hunters wiped out 88% of this incredible megafauna. Section 5. Accuracy versus the algorithm. Which brings us to a major battle happening right now on our screens. How do you actually balance high viewer engagement with rigorous scientific accuracy? Well, one highly successful strategy is the gamification of science. Channels like Tierzoo brilliantly use video game metaphors, treating evolution like balance patches and physical traits as character stats. It is a fantastic way to make complex ecologies super accessible, especially to younger viewers. But it does come with a risk. By forcing animals into rigid tier lists, the content often introduces a predatory bias. It ends up overvaluing the offensive stats of carnivores while kind of downplaying the incredibly successful defensive and reproductive strategies of herbivores. So the crucial point is that while gamification is a fun, creative choice, there is a much darker side to digital paleontology driven purely by the algorithm. We're currently seeing a massive epidemic of what researchers call AI slop. This is automated, low-barrier, short-form content that actively distorts the fossil record just for cheap clicks. We're talking total sensationalism like falsely claiming Titanoboa is still hiding out in the Amazon today. It includes gross anatomical inaccuracies generated by AI, things like incorrect postures or missing feathers, and it heavily features acoustic exaggeration, basically slopping terrifying movie monster roars onto dinosaurs with zero basis in bioacoustic science. Now compare all that algorithmic clickbait to the intense, peer-reviewed rigor that dedicated long-form creators actually rely on. Just look at the math right here. This isn't a random guess. This is the true mathematical equation researchers use to model the population density of a giant herbivore like Diprotodon. They're mapping its theoretical limits based on its body mass, calculating density by taking 10 to the power of a complex logarithmic equation. And this mathematical modeling proves that massive species had very low demographic resilience, making them highly vulnerable to extinction. Now, that is real science, and it takes serious time and effort to translate that level of rigor into an engaging narrative, which is way harder than just churning out an automated fake dinosaur roar. Which leaves us with a really critical question for our digital age. As algorithms increasingly dictate the educational content that lands on our feeds, will the constant quest for digital virality elevate deep-time science to amazing new global audiences? Or will it ultimately rewrite our understanding of Earth's ancient past with sensationalized fiction? The next time a giant extinct monster scrolls across your screen, I want you to ask yourself, are you looking at the fossil record or just the algorithm? Think about that. Keep questioning what you watch, and I'll see you on the next explainer.